kinematic equations for uniformly accelerated motion. Here, uniformly accelerated, it implies that acceleration of the particle or the object that is constant one. Now, suppose we have velocity time graph for any particular uniformly accelerated motion. So if acceleration is constant, uniform means graph is a straight line graph, we can understand. Suppose at time t equal to 0, the velocity is v0. And at some time t, the velocity is v. Now, first of all, we have to calculate acceleration. Now, suppose we take acceleration first, then acceleration, that is change in velocity upon time interval. At time t equal to 0, velocity is v0. At time t, velocity is v. So change in velocity, that is v minus v0. Upon time interval, that is t minus 0. So from this one, we can write at, take this t on left hand side, that is equal to v minus v0. So finally, our equation that we can write v equal to v0 plus at, this is one equation. And from this particular equation, we can write t equal to v minus v0 upon a. Keep it as it is. Later on, we will use this equation. Now, we already discussed area under the graph will give you displacement. Now, x displacement, that is equal to area under this graph with respect to time axis, that is the area of this trapezium ABDOA. Now divide this one in two parts, the triangle ABC and the rectangle ACDO. So area under the graph, that is area of triangle ABC plus area of rectangle ACDO. So x equal to half area of triangle, that is base BC into height, okay, sorry, base AC into height BC, plus the area of rectangle, that is OA into AC. So x equal to half into, now see this portion BC, that is v minus v0, because we see that is BC, that is this much portion. Okay, so these two, this is v, these two, this is v0, so this portion is v minus v0. And A to C, that is t. So we can write half BC, that is v minus v0, AC, that is t. Then OA, that is v0 into AC, A to C, that is equal to OD, so that is t. So we can write v0 t. But now this v minus v0, that we have to replace by AT. So now here we can write, if we take v minus v0, that is AT, then this our equation x, that is equal to this v0t as it is, and here half into AT into t, so that will be half AT square. So this one is our second equation. Then after, simplify this equation, half into Vt minus half into v0t plus v0t. Now minus half v0t plus v0t will give you plus half v0t. So from this one, we can write v plus v0 by 2 into t. But this v plus v0 by 2, that is called average velocity. So here, this one, another equation of average velocity which we obtain in this one, that you have to remember. In case of uniformly accelerated motion, you can calculate the displacement, that is equal to average velocity into time. And average velocity, that is initial velocity plus final velocity by 2. Now, in this equation, v plus v0 by 2 as it is, and t. Now, t is replaced by this equation. T equal to v minus v0 by a. So, substitute here t, that is v minus v0 by a. So, x equal to v plus v0 into v minus v0 upon 2a. So, we can write that is v square minus v0 square by 2a. So, finally, we can write v square minus v0 square equal to 2ax. So, this one equation v equal to v0 plus at, second one x equal to v0 t plus half at square, and this third one v square minus v0 square equal to 2ax are called the kinematic equations for uniformly accelerated motion. These equations are very important. We will use these equations up to standard 12. In any type of motion, under the effect of any type of force, whenever the acceleration is constant, it implies that now you can use either of this equation to explain the motion. Clear? Now see, here when we derived these equations at that time, we considered initial position of the particle or the object was 0. But suppose particle have some initial position. If at time t equal to 0, the position is x0, and at time t equal to t, the position is x. Then in these equations, we have to replace x by x minus x0. Here also x that we have to replace by x minus x0. So if initial position is given to you, then you have to use the equations in this manner by considering that initial position. Clear to all of you?